I am currently working on some scripts for some upcoming videos that I'm doing on astronomy, and I'm working on the evolution of stars. So what happens with low mass, medium mass, and high mass stars at the end of their main sequence stage, which is where they run out of hydrogen to fuse and then start fusing heavier elements. Today I worked on the heavy stars, so they go, supernova or black hole. Well, they go supernova, which can create a neutron star or a black hole, basically. And it's so incredibly confusing. I don't have a degree in this. These are education degrees, and well, one's a science education degree. And I'm not even really all that great at math, and these concepts are so beyond me, but I'm trying to just get the basic understanding of it, which is really frustrating because I know enough, at least, to know that a lot of the stuff I'm hearing and reading is conflicting, or it's worded sloppily and confusingly. So case in point, I'm trying to learn, which stars, how big does the star have to be in order to create a black hole, for example? And some sources will say the star needs to have 20 solar masses, so 20 times the mass of the sun. Others will say the core of the sun needs to have a stellar mass of 2.8, so 2.8 times the mass of our sun. But they'll just use those sort of interchangeably. They won't say that it's just the core of the star that needs to have a mass of about 3 times the mass of the sun. They'll just say it needs to have a mass greater than 3 or whatever. And so you're wondering, did they mean the entire star or did they mean just the core? And why just the core? That's not really explained very well in any of these. I'm trying to make my videos cover all the bases, but also be relatively easy to understand. I guess I never said what I learned today, which was specifically the overall star has to have a mass 20 times that of the sun to go supernova, or you could say just the core of the star needs to have a stellar mass of about 2.8 times or greater that of the sun. I'm also running into a huge problem with understanding iron fusion. So if anybody who's an astrophysicist watches this, which won't happen, but I am really desperate. Iron fusion. I know that iron fusion absorbs energy rather than releasing it, and that's what triggers the collapse of the star, and then the collapse of the core of the star, and then the collapse of the remaining mass of the star, and then the supernova. But here's what I don't understand. Does the fusion of silicon, which produces iron, does that absorb energy? Or is it when the iron nuclei try to fuse? Does that absorb energy? Because I hear conflicting things. The way it's worded, it's impossible to interpret. Do they mean the fusion of iron or iron fusion? Because iron fusion would mean you're fusing iron nuclei together. So I don't know which one it is. And I tried to look it up, but the internet is really not a lot of help, unfortunately. So if anybody knows, please help me out. Thanks for watching.